See, I told you don't like fish. I don't like fish. All right, guys, here we go. We are officially starting to graph a linear equation. If you remember, last week we started identifying a linear equation as linear, nonlinear. Then we kind of went off into a slope tangent, your rise over your run, your rate of change, just to make sure that you know how to use it when we get to the graphing. So now we're officially going to start graphing. And I know you guys usually have a bad attitude with, oh, graphing. But I'm telling you, every year you guys kill this section on graphing because you remember it from Algebra 1. It's not the first time you've been asked to graph a straight line. Okay, so when you are graphing a straight line, guys, there's only 4 things a straight line can do. It can slant to the right and rise. It can slant to the left, and we call that a falling line. It can be vertical, or it can be horizontal. That's the only 4 things a straight line can do. So when you go to graph it, the slope will tell you which one of these lines you get. So it's important to remember which slope goes with which kind of line. So guys, let's call this 1, 2, 3, and 4. If a slope is positive, which kind of line does it create? 1, right? A positive sloping line will go up to the right. So when you graph a line that has a positive slope, it better look something like that. If it doesn't, you graphed it wrong and you can catch your own mistake. All right, if you have a slope that is negative, then what kind of line does a negative sloping line look like? Like 2, right? We call that a falling line. I kind of say it slants to the left, but it's a falling line. Y is going down as X gets bigger and bigger. And then you had your 2 special cases. I consider a vertical and a horizontal line a special kind of straight line. So do you guys remember, if the slope was 0, so think of it as flat. It is 0 rise, nothing. It created what kind of line? 4, a horizontal line had a 0 slope. And then if your slope was undefined, then what kind of line had an undefined slope? Your vertical, your straight up and down line had an undefined slope. So keep that in mind when we start graphing. So you can maybe catch a mistake if your line doesn't slant the way it should according to its slope. All right, and then last I asked you guys, I told you guys, a straight line passes through the point -4, 1, and it has a slope of 2/3. Use this information to create the graph of a line by plotting the point first and then using the slope to move. All right, guys, that's all you need. If you know a point on your line and you know the slope, the rate at which it is changing in between each pair of points, then there's no line you can't graph. So all you have to do is plot your point first. So -4, 1 is left 4. And up 1, that is a point on your line. Now you're going to use your slope, this rate of change, to create another point. So guys, do you remember the 2 R words that help you remember who slope is? Rise over run. So the top number of your fraction tells you to rise up if it's a positive number, down if it's a negative number. The bottom number of your fraction is your run number, and you run side to side. So you will run to the right if it's a positive number, and you will run to the left if it's a negative number. And that's how you're going to use your slope to move to the other point. So guys, if our slope is 2/3, how do you rise 2? Would that be up or down 2 units? Up, because it's positive. And then how do you run 3? Would that be to the right or to the left? Right 3. So your slope is up 2 and right 3. So count up 2 spaces and right 3 spaces and put another dot. That's where the next point on your line is going to be. Up 2 and right 3. Now guys, at the end of the day, if you're graphing a straight line, all you need are 2 dots. Connect them and you got yourself a straight line. I usually ask you guys, just keep counting your slope a few more points so you get a really nice picture of your line. So I'm going to go up 2 and right 3 again. Because remember, this is why these lines are straight, because they have the same rate of change in between every pair of points. So I can go up 2 and right 3 again, and I'm creating that beautiful, perfect straight line. Now guys, do you remember when we were doing slope? I told you that every line, it only has 1 slope, but there's a couple different ways that it might look. So if you have a slope of 2/3, that's the same as this. Because what's a negative over a negative reduced to? Positive. So this is the same as that, except this one gets you going in the other direction. Now, to go this way on my straight line, I could go down 2 and left 3, which tells me this slope. So all you have to do to go the other way is the exact opposite as to what you did the first time. If you went up 2 and right 3, well then to go the other direction, go down 2 and left 3, and you still create that perfectly straight line. Okay? All right, so that's what we're going to be doing today. We're going to be graphing straight lines, but we have to do it from their equation. They won't necessarily just tell you the point and the slope. We have to take it from its equation. All right, so let me give you your notes. And we'll go from there. You pass call? Yeah. Just sign it real quick.
You sign?
Yep. Thank you. Can you pass the Okay. All right, so guys, we're finally going to do it. We're going to graph a linear equation. Just a couple things I want to review before we do that. First of all, if you're going to graph a linear equation, I want everybody to remember what it means to be a linear equation. A linear equation was a degree 1 equation. Guys, a degree 1 equation means who's the highest exponent on a variable? 1. That means you don't got to deal with any x squares or any x's to the third. This is as simple as these equations are ever going to be. It's just x and it's just y. All right, so it's a degree 1 equation that can be written in the form y equals mx plus b. Everybody's favorite formula. You guys are going to be 90 years old and still remember this formula. That is called slope-intercept form of a line. All right, and we saw that the graph of a linear equation is always a straight line. And the reason it's always a straight line is because of that slope, because of that constant rate of change in between every single pair of points. All right, well guys, then I showed you in section 2.2 that a linear equation can be written in 2 forms. One of them is our favorite, slope-intercept form. A linear equation can be given to you in slope-intercept form, and we love it. We remember that formula from Algebra 1, and when you're in this form, x and y represent all the ordered pairs that are going to be on this line. But m and b are going to be replaced with numbers, and they are going to be representing, m is going to represent the slope of that line. So that's going to be your rate of change. The number in front of x always represents the slope of that linear equation. So that's always going to be your rise over your run. And then the B always represents the y-intercept. It is a point directly on the y-axis. All right, so if you are a y-intercept, that's basically them giving you a start point. That is the point that you can plot to get your line started. But guys, remember, a y-intercept, he is the point where your graph crosses the y-axis. So he is somewhere directly on the y-axis. And to be on the y-axis, that means he always has an x-coordinate of 0. It'll always be the point 0 is x, and then b, whatever number they gave you in the equation for that y-intercept. All right, but it is always directly on the y-axis. It is a y-intercept. Okay, if a linear equation is not given to you in slope-intercept form, then it's going to be given to you in standard form. And you've seen this too. This is ax plus by equals c, where x and y are always going to be in the equation to represent all the ordered pairs that are going to be on this line. But a, b, and c will be replaced with numbers. So maybe it'll look like this, 2x plus 3y equals 9. You guys should recognize those. Those are the ones that you are always asked to solve for y, because you're going to try and get it in slope-intercept form. But the problem with standard form is The numbers that are in his equation, the 2, the 3, and the 9, guys, by themselves, they don't have any meaning. They're not the slope. They're not the y-intercept. They're just random numbers in this equation at that point, which is kind of why we usually don't like standard form, because we don't have any important information right from the equation like you do with slope-intercept, okay? All right, so those are the 2 ways the equation is going to be given to you when you are asked to graph. So let's graph the ones that are already in slope-intercept form first, because they're the best and they're the easiest. All right, so if you graph a line that is already in slope-intercept form, I wrote down a list of steps just in case you need them when you're on your own. When you graph a line in slope-intercept form, the first thing you should do is identify your slope, your m, and your y-intercept, your b. Then you're going to plot your y-intercept first on the coordinate plane, and you're going to use your slope to move to other points. I remember my teacher used to always say, you begin with the b, the y-intercept, you move with m, your slope. All right? All right, so guys, let's say we had to graph this. Y equals 2/3 x minus 4. You have to graph that equation. Do you agree it's already in? Oh, BB3. Hey, what's up? I do. Can I hold on for 5 minutes? All right, thanks. Bye. Andrea, after I've done this example, they need you in the office real quick. Okay? All right. Unless you want to wait even longer. I'll tell them you stay to see the notes. That's up to you. All right? So do you guys agree this is already in y equals mx plus b form? Yeah, it's great, right? So who's m? Who's the number in front of x that's going to be our slope? 2/3, beautiful. So there's your slope, there's your rate of change, your rise and your run. And then who's your b? Who's your y-intercept here? -4, which guys means it's a point directly on the y-axis. So his x-coordinate is always 0. And obviously the y-coordinate is -4. So that is literally the point, 0, -4. So to graph this line, we're going to start with our point, our y-intercept, and we're going to move with the slope. So guys, let's plot this point. Guys, it's a y-intercept. It has to be directly on the y-axis. So where is y -4? Up 4 or down 4? Down. So down 4 and put a dot. That is your y-intercept. We also call that, he's like the start point of your graph, because this is what y is equal to when x is 0. So when you haven't started yet, this is where the graph starts. All right, now from here, let's use rise over run. How do you rise to? Up 2 or down 2? Up 2. How do you run 3? Right 3 or left 3? Right. Right 3. And that's how we move. Up 2, right 3. Up 2, right 3. Just keep counting it until you fall off the coordinate plane. All right, so that's how we go in this direction. If I go back, to my y-intercept, and I want to go the other way, guys, do the exact opposite of up 2, right 3. Don't go up 2, go down 2. Don't go right 3, go. And you should still see that perfectly straight line get formed. And then you're done. I'm falling off the coordinate plane. Connect your dots, and you have a beautiful straight line. Okay. Now again, students are always like, oh, Hardy, I hate graphing. Like, why do we got to do it? I get it. But guys, from a math standpoint, the graph is like so important. Because I don't know if anybody ever sat here and said, man, I wonder what all the answers to this equation are. What are all the x and y values that make it true? Well, guys, that's exactly what a graph shows you. A graph is basically a cheat sheet to all of this equation's answer. Any ordered pair that lands on this line is a solution to this equation. So guys, do me a favor. What point is this? What ordered pair? 0, -4. That means when x is 0 and y is -4, this equation will be true. When x is 0 and y is -4, that equation will be true. Guys, what's 2/3 times 0? What's 0 minus 4? -4 equals -4. This is a solution to that equation. Guys, what point is that right there? 3? -2. That means when x is 3 and y is -2, this equation will be true. When x is 3 and y is -2. Guys, what's 2/3 times 3? What happens to 3 up here and 3 down there? cancels. What's 2 minus 4? Negative 2 equals negative 2. That is a solution to this equation. That is what a graph is showing you. This graph is showing you all the solutions to this equation. So it is very, very meaningful. It is a cheat sheet to all of its answers. If you are a point that lands on this line, then you are a solution to that equation. That's what the graph is showing you. It's really, really important. All right, let's try this one. If you had to graph the equation y equals negative 3x plus 1, do you agree it's in y equals mx plus b form? Yeah. Great. So who's m? Who's our slope? Negative 3. And guys, it's supposed to be a fraction, so you have a rise and a run. How do you make him a fraction? Over 1. Just throw a 1 under it. You got a rise and a run. All right, and then who's your b? Who's your y-intercept? 1, which means the x-coordinate is always 0. The y is 1. That is the point 0, 1. It is your y-intercept right on the y-axis. All right, so let's graph him first. Where would the point 0, 1 be? Up 1 or down 1? Up 1. That is the first point on your line. That is the start point. Now let's use his rate of change to move to more points. So guys, how do you rise negative 3? Down 3. And how do you run 1? Right 1. So go down 3 and right 1. That is the rate of change. Down 3, right 1. So guys, you're dropping 3 times faster than you are moving to the right. So it's going to be a pretty steep line. So keep going. Down 3, right 1. If I go down 3 and right 1 again, I'm off the coordinate plane. So let's go back here and let's go the other way. So instead of going down 3, right 1, go up 3 and left 1, because technically that's him. They're the same thing. I can go up 3 and left 1 and still be graphing the exact same line because they mean the exact same number. I can go up 3 and left 1 more time, and there's your beautiful straight line. And if you notice, this one had a positive slope, it slanted to the right. This one had a negative slope, it slanted to the left. So everything's doing the right thing. And then again, these are all the x and y values that will make this equation true. Okay? All right, let's try another one. I'm trying to throw all different scenarios at you. Look at example 3. And I'm not trying to trick you, so please let yourself say yes. Is this a linear equation in y equals mx plus b form? Yes, except who is clearly the m here? Who is our slope? The number in front of x is negative 5 over 2. Now, guys, when math does this, when they tell you it's a negative fraction, you can't give the negative to both numbers. Otherwise, that would be a negative over a negative, and that's a positive. So you can only give it to one of the numbers. My rule is always give it to the top. Always make it the negative number on top and the positive number on bottom. So I'm going to think of this as negative 5 over positive 2. All right, and then who's our y-intercept? Assumed to be if they didn't put anything out here. It's got to be 0. Now, guys, a lot of students want to say, oh, it's 1, right? They would have to put +1 or -1. The only time math is allowed to assume a 1 is there is something that would be in front of a variable. You can assume there's a 1 in front of that x. You can assume there's a -1 in front of that x. But you can't assume there's a +1 out here. They would have had to put that if they wanted a +1. So the only thing we can assume is that it's plus nothing, +0. So now who's the y-intercept of this graph? 0. So that means that x is 0 because it's always 0, and then your y-intercept is 0. So it just means that the very first point on your line is right there. What do we call that dot right there? Starts with an O. The origin. It just means that the graph starts at the origin. All right, so that's your first point. Now we use rise over run. Guys, how do you rise -5? Down 5. And how do you run +2? Right 2. And then again, if you go down 5 and right 2, I fall off the graph. So I'm going to go back up here, and I'm going to do the exact opposite. Instead of down 5, right 2, go up 5 and left 2. And then there's that perfectly straight line again. If your line or your dots are crooked, maybe you're counting wrong. So just be careful. It should be a perfect straight line. All right. Before we go on to standard form, I want you guys to do example 4. Get your slope, get your y-intercept, and graph that line. Yeah.
I don't know.
Andrea, I don't know if you want to go, but I'm going to do standard form next, which means you just have to solve for y first. I don't know how you feel about that. If you want to see one of those. I don't know. Okay. You don't have one? Okay.
I think it's going to pass that.
We're going to get, no, because we're going to get new ones for December.
Oh, okay.
So don't worry about it.
Thank you.
Yep. What you got? What's up? Oh, does it? Oh. They make you go outside in this weather?
Yeah.
I already resorted back to the treadmill. I run inside now. I don't like too cold.
I don't know why I signed up for track, but I hate it.
You hate it? Because it keeps you in shape, that's why.
Yes, sir.
Does everybody agree your line looked like this? You had a slope of -1, was assumed to be there. Put it over 1 to make it a fraction, and then your y-intercept was -2, and you have a beautiful, nice sloping line like that. Awesome. Yes, Al. All right, so then what happens if the equation is in standard form, not slope-intercept form? So guys, technically, when they give you a linear equation in standard form, you're actually going to have options. And oops, Spike got tired. You're actually going to have options as to how you want to graph it. I'm going to train you to stay with the whole y equals mx plus b. We're going to take standard form, and we're going to get y by itself to get it back in this form. And then you'll be right back on track. You can get your slope, your y-intercept, and graph. However, in a day or two, I'm going to show you the other alternative to graphing in standard form. Another way to graph a straight line when it's in standard form is to find your x and y-intercepts and then use those 2 points to graph it. We're not going to do that today. We're going to hold off. Let's wait. Let's stick with the whole slope y-intercept. Okay, so when it's in standard form, I want you to solve the equation for y. We've trained for this. We can do it. We're good. All right, by getting y by itself, you're then putting it in y equals mx plus b form. Then you can get your slope, your y-intercept, plot your y-intercept, use your slope, and you're right back to what we were doing. Okay, so guys, if I asked you to graph x minus 4y, hey.
Can I steal one of your kids?
Yes, I'm sure they would love you to. Let's go, Brendan. Good luck. All right. I feel like we're all asleep. Sorry. What am I saying?
Real quick before I bother you.
Yes.
Is he any good or is he bad?
Brendan could teach my class. He's that good.
Good. Oh,
Right?
wow.
In fact, he did one day, and I think he did a fantastic job. I think we could have a future teacher and coach in our list here. He's got the personality for it. All right. So if you are given, are you going to varsity practice today, Brendan? Are you?
Yes. That's crazy.
We're going to see Brendan out there scoring lots of points. Let's go. All right. So when you are given an equation in standard form, your first job is to get y by itself. So guys, we're good. What's the first thing you're doing to get that y alone? Minus x. I even suggested in the past, maybe put a 1 in front so that when you get to the division step, it helps. So I'm going to minus my 1x to the other side. That's going to leave me with -4y's equals. Guys, we can't combine them. They're not like terms. So I tried to get you in the habit of putting the x's first, -1x, and then the -12 after it. That was already there. What's the only thing you have left to do to get y by itself? Divide everything by -4. All right, so now we're not going to lose any signs. Y is alone. Negative over a negative reduces to a what? And then 1 does not divide by 4. It does not reduce. So now it's just going to be +1 over +4 times x. And then what's -12 divided by -4? +3. And guys, we are right back in business. Go ahead, Chris.
I guess this would be wrong. I put X over 4.
No, you're not. You're not wrong. The problem is, Chris, X is never part of your slope. Your slope is a number. So then you'd have to say, wait a minute, X is not my slope. Who's in front of X? 1. My slope is 1 over 4. So again, you're not wrong. It's just you can never say, though, that X is part of your slope. Slope is a number. All right? All right, so here we go. So guys, who's our slope?
3.
Slope. 1/4. And then who's your B? Your y-intercept? 3, which means he's directly on the y-axis, so his x-coordinate is 0, and his y-coordinate is 3. All right, so guys, we're just back. Let's plot our point. Where would the y-intercept be 3? Up 3 or down 3? Up 3. And then we're using our slope. Rise over run. How do you rise 1? Up 1. How do you run 4? Right 4. So up 1, right 4. If I go up 1 and right 4 again, I'm a smidge off, but I can make it work. And then if I want to go the other way, instead of going up 1, right 4, go down 1 and left 4. And there's that beautiful, very, very almost flat straight line because you are only moving up 1 and right 4. So you're going side to side 4 times faster. All right, I want you guys to solve this for y and graph it. Andrea, if you feel good, you can go. Andrea. All right. So solve that for y and graph it. Do you guys feel like you remember this, that it feels pretty, usually I'm telling you guys, as much as you don't like graphing, this is pretty good. Yeah.
Okay.
There's 2 out, but yeah, well, Abby's still waiting.
I think it was a lot harder.
No. Abby, why don't you go, and then when the next one comes back, Chris, you can go.
I feel like this is a lot harder in 8th grade.
Maybe. I just think it's crazy that you saw it in 8th grade, and yet you're still asked to do it as a junior. I shouldn't have to do this. That's all right. It works. We're getting a new one Wednesday.
I'm mentally not here right now.
That's okay, Brendan. I understand. There are bigger things happening than slope and y-intercept in your life right now. But Belle will lose sleep tonight if I don't finish these notes. So hopefully you have the same equation as me. Didn't lose any signs. Your slope should be -2 over 3. That's your rise and run. Your y-intercept should be -4. So x is 0, y is -4. So I'm going down 4 to my first dot. And then I'm using -2 over 3. Rise over run. Down 2, right 3. Or up 2 and yeah. And there's your perfect straight line. It is also all the solutions to this equation. And you always want to put the arrows to imply that, guys, this line could go on for the rest of our lives, just creating more and more solutions to this equation. All right. Well, guys, the only thing you have left then is we saw what happens when a line slants to the right. We saw what happens when a line slants to the left. What about our horizontal and vertical? So let's look at those last section of the notes. Horizontal and vertical lines, guys, they're meant to be basic and simple. However, there's no strategy to graphing them other than you reasoning it out. So it can be a little bit difficult, but you just kind of got to wrap your head around what's going on. All right, before we start graphing them, horizontal and verticals, I want everybody to look at the equations first. Look at this equation, look at this one, look at this one, and this one. These are the equations to horizontal and vertical lines. Normally, we're graphing lines that are in y equals mx plus b form, like y equals 1/2 x plus 3. So x and y are part of the equation, but then m and b get replaced with numbers. But how many variables do these equations have? Only 1. So guys, that's the dead giveaway that you are being asked to graph a horizontal or vertical line. Their equations only have 1 variable. So it's only going to have an x. or it's only going to have a y. That's how you know, oh, okay, red flag. These are horizontal or vertical lines. Once you kind of see that, then all you have to do to graph it is do exactly what it says. So guys, look at this one. How many variables do you see? Just one. Is it already by itself? Yes. And it says y must equal -5. That means every single dot on this line has to have a y coordinate of -5. It is the only y coordinate allowed on this line. So guys, do yourself a favor. Go on your graph. Where is y -5? Up, down, right, or left? Down 5. So go down 5 and put a dot, because that is definitely a y coordinate of -5. Now, the next dot that you put on this graph also has to have a y coordinate of -5. So guys, watch this, don't do it though. If I put a dot right here, does that have a y coordinate of -5? No, it's got a y coordinate -4, so you can't go up. If I put a dot right here, does it have a y coordinate of -5? No, it's got a y coordinate of -6, so I can't go down. So I can't go up, I can't go down, I can't slant because we already know these are horizontal or verticals. That means the only place you can go is right or left. Guys, if I go to the right of it, does it still have a y coordinate of -5? Yes. Yeah, that's the point 1, -5. If I go to the right again, does it still have a y coordinate of -5? Yeah, it's the point 2, -5. If I go to the left, does it still have a y coordinate of -5? Yeah, it's the point -1, -5. So when all of the y coordinates have to be -5, what kind of line did it form? A horizontal line. So that is a horizontal line where every single dot on it has that as its y coordinate. You just have to do what it says. All right, look at this one. This one has how many variables? Just one, so we know it's special, we know it's horizontal or vertical. Is that one variable by itself?
Yes.
Yeah, so we're good to go. Just do what it says. Graph what it says. Graph a line where every single x coordinate is equal to 4. So guys, where would x be for? Up, down, right, or left? Right, we're on x now. All right? Now we have to have another dot that has an x coordinate of 4. So guys, don't do it, but watch me. If I put a dot right there, is x still 4? No, that's where x is 5. If I put a dot right there, is x still 4? No, that's where x is 3. So I can't go right, and I can't go left, and I can't slant because I know it's horizontal or vertical. So that only leaves up or down. So guys, if I put a dot right here, is x still 4? Yeah, that's the point 4, and y is 1. If I put a point right here, is x still 4? Yeah, it's the point 4, 2. If I put a dot right here, is x still 4? Yes. Yeah, that's the point 4, -1. So what kind of line is formed when x has to stay the same? Vertical. So you should know your horizontals or verticals because they only get one variable, and then all you have to do is create a line that does exactly what they say. So guys, look at this one. How many variables do you see? Just one, so it's horizontal or vertical, but you got to get it alone. So what's the only thing you have to do to get this y alone? And we're used to solving for y, so it kind of still feels normal. You get y equals 2. So guys, where would y be 2? Up, down, right, or left? Up 2, put a dot. That's definitely a point on your line. Now give me another dot that also has a y coordinate of 2. Can I go up? Can I go down? Can I go right? Yeah? Can I go left? So what kind of line is it? Horizontal. All right, last one. How many variables do you see? 1, and it's x. And we're not used to solving for x. Normally we solve for y. But guys, he's the only variable here, so you got to do it. So we'll solve for x. Divide by 5. And you find out that x has to constantly be who? -3. So we have to graph a line, vertical or horizontal, whichever one it ends up being, where x is constantly -3. So where would x even be -3? Up, down, right, or left? Left. So that's where x is -3. Can I go right? No. Can I go left? No, but can I go up? Can I go down? So it's a vertical line.
So how would you do these questions by just making a line?
The graph is the line. The graph is the answer. Mhm. All right, how do we feel, okay? All right, guys, it seems like you're doing really, really well. You do have a homework on Delta Math, but here's the good news. As important of this is, Delta Math only had problems for me to assign you where everything was already in slope-intercept form. So all of your homework tonight is already in slope-intercept form, so you don't have to worry about solving for y. And they didn't have any horizontal or vertical line examples. So everything will either slant right or slant left, okay? Tomorrow, I'll try to get you some horizontal and vertical line practice. All right.
No, good track, bro.
Really?